In this video, we are going to now talk about area. Area is a little bit more complex, a little more challenging than perimeter. Different shapes that definitely have different formulas to it. Perimeter, you were just adding all the sides together, where area just kind of depends on the shape. But a lot of them are very much a base times height kind of a thing. And a base times height, they are the base and the height are the two pieces that are perpendicular to each other. All right, so if you have a parallelogram, you don't have to worry about all the sides. It's just figure out what the height is, multiply it by the base. On a rectangle, the length and the width are the bases and the heights. So really it's the same idea. A square is side times side squared, because it's just base times height. So all three of these are exactly the same. In fact, all four of these are exactly the same. Base times height. The difference is the height is actually part of the side, where the height here is just the distance from the top to the bottom. When you get to a trapezoid, also you have a base times height. The difference is you're going to add two bases together, which are your parallel sides. So you're adding your parallel sides, multiplying it by the height, which is the gap between them, and then you're taking half of it. And the trapezoid has kind of the same feel as a triangle, where base times height, but then you got to divide it by 2 or multiply it by half. Same thing. So the last one is what if you don't know the height? There's all sorts of calculations that you can do to figure out the height, but you'd have to like break the triangle up. It's definitely, there's some math involved to it. Somebody figured out that there was a shortcut to it. There's just a formula. And the formula looks like this, and it's complicated looking, but it's just a formula. So you just plug stuff in. So you have this A, B, and the C, which would be the sides that you would know. What you wouldn't know is this value on the inside, and you're not going to know the value on the inside at any point. This S is just kind of part of the formula. So it's S times S, and there's an S, and there's an S. So you have to figure out what the S is, which is by doing this calculation right here. Adding all the sides together, multiplying it by half, cutting it in half, and then whatever that value is going to be here, 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 and here. And then you'll subtract the side, subtract the side, subtract the side, and then eventually multiply it all together. And then the last thing is to do the square root of it. Okay, so we have 3 of these, and the last one is we don't know the height of these, so we're going to have to end up using that formula. Okay, so the first 2 are going to be pretty straightforward. Is you're talking about an area of a trapezoid, so you're looking at we're going to add the parallels together, multiply it by the height, cut it in half. And that's all exactly the information that they give us. So it's going to be 1/2 the height, which is 4. And then the sum of the parallels, which is 9 plus 13. So if you start doing the math here, 9 plus 13 is 22. Half of 4 is 2. 2 times 22 is 44. Now, remember what this whole idea of an area means is it's this space within. So it is, if this is labeled as centimeters, that means you are trying to put these little squares in here that are 1 centimeter by 1 centimeter in size. And you want to know how many of these little squares would it take to fill up this whole area. It's like you're trying to tile a room, and this is the shape of the room, and these are the size of the tile, 1 centimeter by 1 centimeter. You would need 44 of them. So it'd be 44 centimeters squared. So 44 square centimeters would take to fill up that space. All right. And then a triangle, totally the same idea, different formula. This one is 1/2 base times height. So the base is the 8. The height is 6. And so our area is half of 8 is 4. 4 times 6 is 24. And then we'll label it with square inches. So this time it would take 24 inch by inch little squares to fill up that space. All right, so the last part is the more complicated one. This one, it gives you values of a triangle, but it doesn't give you the height. So I'm just going to draw my triangle. Not at all trying to make this thing to scale. Just want a visual. All right, so those are our things. We don't have this height right here, and we're not going to get the height. So instead, we use that formula. So the first thing we need on this formula is actually the S. We need that. Okay, so we need S. So our S is going to equal 1/2 the sum of all the pieces. 8 plus 15 plus 19. So if you add all that together, that adds up to 42. We take half of that, which is 21. So now we can jump into this formula. So we have our S, which is 21. So it'll be 21 here, 21 here, 21 here, and 21 here. And then we're going to subtract the sides from each of them. Okay, so our area is going to be square root of 21 times 21 minus one of the sides times 21 minus second side times 21 minus a third side. All right, so this becomes 21 times 13 times 6 times 2. So if we multiply all of that together, we are looking at square rooting 3,276. And then if we throw that in the calculator, we'll square root the 3276. Our area is going to be 57.24, and they were saying round to the nearest hundredth. So 57.24, and we are in inches, square inches. Now that may seem like, well, there's a lot of steps involved in that, but us having to drop a height down and then use some trigonometry is the only thing we'd be able to use to figure it out. This ends up being a lot nicer and quicker way of figuring out our area. All right, so we have our formulas for any other kind of shape that comes our way, but we were finding areas of different polygons.